Guadalcanal, August 1942. Through sweat-fogged field glasses, a Japanese officer tracks his battalion, 120 soldiers cutting through tall grass toward a Marine defensive position. 40 Americans, maybe fewer. The arithmetic feels ancient, reliable. Overwhelming numbers crush smaller forces. This is how battles end. Then the sound changes everything. It's not the familiar bolt-action bark, that methodical crack-pause-crack rhythm, where riflemen manually chamber each new round. This is something else entirely. A sustained thunder, individual weapons creating collective devastation. Through his optics, he watches his troops fall in waves, not scattered casualties. Entire groups collapsing simultaneously. 3 soldiers down, now 5 more. A squad leader, 6 years of shared service, drops mid-stride. The Americans aren't cycling their weapons between shots. They're simply firing, again, again, again. 8 consecutive shots without pause, a fluid reload motion. 8 more rounds downrange, 90 seconds. He counts reflexively, officer training calculating combat tempo automatically. 90 seconds. 47 casualties. Dead or critically wounded before his force even reaches effective engagement distance. The assault disintegrates. Men who'd charged machine gun positions in Manchuria seek cover desperately. The survivors crawl backward through the kunai grass, not routing, not yet, but the advance is finished, shattered against a volume of fire that shouldn't exist from so few defenders. His hands shake now. His company, 120 trained infantrymen, just got stopped cold by 1/3 their number before closing to rifle range. That night's after-action report, written by flashlight, stays clinically professional. Enemy equipped with automatic rifles capable of sustained rapid fire without manual operation. Request machine gun support for all future engagements. He uses automatic because he has no other reference. Rifles are bolt action, machine guns are automatic. What he witnessed fits no category his training ever covered. They weren't automatic rifles. They were M1 Garands, gas-operated, semi-automatic, chambered in .30-06 Springfield, 8-round en-bloc clip. Effective range, 550 yards. Weight, 9.5 pounds. And the number that changed everything, 40 to 50 rounds per minute sustained. A trained Marine could maintain that pace indefinitely, limited only by ammunition supply. His troops carried Type 99 Arisakas, superb bolt-action rifles, accurate, reliable, well-made. But bolt-action physics can't be rushed. Even the most skilled rifleman manages perhaps 10 to 15 aimed shots per minute. The mechanical cycling demands time. The math was brutal. 1 Marine with an M1 delivered the firepower of 3 Japanese riflemen. In any engagement without 3-to-1 numerical superiority, Japanese infantry faced a firepower deficit that courage couldn't overcome. Tokyo's response seemed obvious. Capture these weapons. Study them. Replicate them. Japanese engineers ranked among the world's finest. They'd successfully reverse-engineered British Vickers machine guns, German optical equipment, Czech pistol designs. When captured M1s reached Tokyo for evaluation, the rifles actually functioned. The gas system cycled correctly. The bolt locked. On the test range, everything worked. On paper, success looked achievable. But when engineers began precision measurements, documenting every dimension, analyzing every component, they uncovered something that transformed the entire challenge. Tolerances machined to 10,000ths of an inch. Springs requiring specific steel alloys, 8 moving parts in the clip mechanism, each demanding exact specifications to function reliably under combat stress. Then they discovered the production scale. Springfield Armory alone, 600 rifles daily. Total M1 production by war's end, over 4 million. Every single one built to identical specifications. Parts completely interchangeable between rifles manufactured in different facilities, different years. Japan's entire 1941 rifle production, all models, all arsenals combined, 162,000 bolt actions, different tolerance standards at different facilities. Parts weren't genuinely interchangeable even within identical model designations. The engineers began understanding what they truly faced. They weren't copying a rifle. They were attempting to replicate an entire industrial civilization.
February 1944. Imperial General Headquarters issues the directive, develop a semi-automatic rifle. Mass production target, 1945. Yokosuka Naval Arsenal, Japan's most sophisticated weapons facility, receives the assignment. The engineers understand immediately what headquarters doesn't want to acknowledge. They've been ordered to perform industrial miracles with resources already disintegrating. American B-29s are systematically erasing supply chains. Steel gets diverted to aircraft carriers and fighter production. Ammunition quality deteriorates as chemical supplies vanish. The empire's industrial capacity is being consumed faster than it can regenerate. But orders are absolute. Japan will build its answer to the M1 Garand, or collapse trying. The engineers make intelligent adaptations. Instead of the unblocked clip system, those 8 precisely manufactured moving parts, they design a 10-round internal magazine fed by standard 5-round stripper clips, the same clips Japanese soldiers already know how to use. Manufacturing stripper clips requires far less precision tooling. They retain the core technology, the gas-operated rotating bolt. That's where the semi-automatic capability lives. They substitute a Japanese tangent rear sight for the American aperture sight because Japan simply lacks production capacity for aperture sights at scale. They specify a 2-piece wooden stock instead of single-piece walnut because Japan's hard wood is already allocated to aircraft propellers and existing rifle production. On the chief engineer's desk, a meticulous man who'd spent 2 decades watching Japan's military consume resources faster than industry could produce them, the design looks like brilliant improvisation. The Type 4 would actually hold 2 more rounds than the M1. It would use familiar loading procedures. It would leverage existing supply chains and soldier training. The modifications seem sensible, even superior in some respects, but each adaptation creates ripple effects through the entire system. The modified magazine changes receiver dimensions, requiring completely new forging dies. The tangent sight alters the sight picture, requiring different training protocols. The gas port needs recalibration for Japanese ammunition, which operates at different pressure curves than American .30-06 rounds. The 2-piece stock changes harmonic vibrations during firing, subtly affecting accuracy in ways that won't appear until live testing. The invisible problem, manufacturing precision. American M1 production relies on infrastructure Japan cannot replicate. 50-ton forging presses for receiver blanks. Hardened tool steel for rifling buttons that can produce thousands of barrels before wearing out. Controlled atmosphere heat-treating furnaces maintaining exact temperatures for exact durations to achieve proper steel hardness without brittleness. Most fundamentally, interchangeable parts manufacturing, the legacy of Eli Whitney and the American Armory System, refined across 140 years of weapons production. Japan in 1944 operates with aging machinery, much purchased from Germany or Britain in the 1920s. Priority steel goes to Zero fighters desperately contesting American air superiority and to warships that can no longer leave port without being sunk. Skilled machinists who understand precision tolerances get drafted into infantry units as casualty replacements. Power shortages from Allied bombing mean factory equipment runs intermittently or at reduced capacity. Summer 1944 brings the first prototypes. 20 Type 4 rifles, hand-assembled by master craftsmen who fit each part individually, filing, adjusting until components mate properly. These aren't production weapons. They're proof-of-concept demonstrations, each one essentially custom-built. Test results reveal fundamental problems. Best case, 40 rounds without malfunction. Typical case, jamming after 15 rounds. Worst case, failure to cycle on the first shot, requiring manual operation like a bolt action. The problems cluster around predictable failure points. Gas port fouling. Japanese powder formulations leave more carbon residue than American propellant, gradually choking the gas system until insufficient pressure reaches the operating rod. Magazine feed lips bending under spring pressure because available spring steel doesn't match American alloy specifications. Extractor failures from inconsistent heat treating. Some extractors too soft, deforming under stress. Others too brittle, cracking under load. Ammunition quality variations causing extraction problems when cartridge case dimensions aren't consistent. An engineer's report from August 1944, later captured by American occupation forces, contains a sentence summarizing the entire endeavor. The American rifle succeeds not through superior design alone, but through superior ammunition, superior metallurgy, and superior quality control at scales we cannot match. The mathematics become impossible to ignore. American M1 production by mid-1944, over 4,000 rifles daily across multiple arsenals, Springfield, Winchester, International Harvester. Japanese Type 4 production, 250 part sets ordered, with perhaps 100 potentially assemblable into functioning rifles. American ammunition, uniform brass cases, non-corrosive primers, consistent powder charges measured within half a grain, is being produced by the hundreds of millions of rounds annually. Japanese 7.7 millimeter ammunition experiences increasing quality control problems as chemical supplies for primer compounds become scarce and waterproofing steps get skipped to save time and costs. Late summer, a crystallizing moment on the test range. A Yokosuka engineer conducts a direct comparison. One pristine Type 4 rifle, fresh from assembly, carefully inspected. One captured M1 Garand, well used, showing wear but functional. Both rifles firing identical Japanese 7.7 millimeter ammunition from the same production lot. Same temperature, same test protocol, same shooter, the M1 Garand. 80 rounds without a single malfunction. The Type 4 jammed on round 23 when the extractor failed to extract a spent case. The engineer cleared the jam, continued. Another failure at round 47. Another at round 62. Same ammunition, same environmental conditions. The only variable, the rifle itself. His report, filed with characteristic precision, we have copied the parts, but not the precision. Each American part fits every American receiver. Each of our parts fits only the receiver it was made for. We are building 250 custom rifles, not a production weapon. He understood what his superiors didn't want to acknowledge. The Type 4 project wasn't developing a weapon system. It was exposing the chasm between Japanese industrial capability and the demands of modern mechanized warfare. By autumn, even the optimists at Yokosuka were running calculations leading to the same conclusion. If Japan somehow perfected the Type 4 design, if every technical problem was solved, if production actually began, the timeline meant perhaps a few thousand rifles by war's end. Meanwhile, American factories were adding 4,000 M1 Garands to inventory every single day. The United States was producing more semi-automatic rifles in 1 week than Japan could hope to produce in a year. The chief engineer kept working because orders required it, and because Japanese professional culture demanded commitment regardless of outcome. But he'd stopped believing in victory. Now he was simply trying to give Japanese soldiers something better than what they had, knowing that better would still be vastly inferior to what they faced. The Type 4 wouldn't change the war's outcome. At best, it might give a few soldiers a slightly better chance of survival in battles Japan was going to lose anyway. The jungle air hung heavy, thick with humidity and the acrid smell of cordite. Captain Tanaka Yoshio pressed binoculars against his face, hands surprisingly steady despite what he was witnessing. 120 men from his company moved through the kunai grass toward the American position. A thin defensive line perhaps 300 meters distant, defended by maybe 40 Marines. The arithmetic felt straightforward, the kind his instructors at the Imperial Military Academy had drilled into him since 1932. Numerical superiority of 3-1. Close quickly, overwhelm with steel. Japanese infantry doctrine had proven itself in Manchuria, in China, in Malaya. Numbers and courage won battles. Then the sound began. Not the familiar crack, crack, crack of bolt-action rifles, where each shot required a man to work his action, eject the spent case, chamber a fresh round. This was different. A sustained roar. Almost like machine gun fire, but coming from individual riflemen. Through his binoculars, Tanaka watched his men begin dropping, not one at a time, in clusters, 3 men down, 5 more. A squad leader he'd known for 6 years crumpled mid-stride. The Marines weren't working their bolts between shots. They were simply pulling triggers. Again, again, again. 8 rounds without pause, a smooth motion to reload. 8 more rounds. The volume of fire was impossible. Tanaka had trained his entire career around the understanding that riflemen needed 3 to 5 seconds between aimed shots, the mechanical reality of bolt-action weapons. These Americans were firing as fast as they could acquire targets, 90 seconds. He timed it reflexively, the way officers learn to gauge combat tempo. In 90 seconds, 47 of his men were down, dead or wounded. It didn't matter tactically. The attack faltered. Men who'd charged machine gun nests in China dove for cover. The survivors began crawling backward through the grass, not routing, not yet, but no longer advancing. The assault had simply stopped, broken against a volume of fire that shouldn't have been possible from so few defenders. Tanaka lowered his binoculars, aware that his hands were shaking now. His company had just been defeated by a force 1/3 its size before closing to effective rifle range. That wasn't supposed to happen. Not to Imperial Japanese Army infantry. Not with 3-to-1 odds. That night, riding by flashlight, he kept his language precise and professional in the after-action report. Enemy equipped with automatic rifles. Each rifleman capable of sustained rapid fire without manual cycling. Request machine gun support for future engagements. He used the term automatic because he had no other frame of reference. Rifles were bolt action. Machine guns were automatic. What he'd witnessed didn't fit any category his training had prepared him for. They weren't automatic rifles. They were M1 Garands, gas-operated, semi-automatic, chambered in .30-06 Springfield, 8-round unblocked clip. Effective range, 550 yards. Weight, 9.5 pounds. Rate of fire, and this was the number that changed everything, 40 to 50 rounds per minute, sustained. A trained rifleman could maintain that pace for as long as ammunition lasted. The Type 99 Arisaka that Tanaka's men carried was a superb bolt-action rifle, 7.7 millimeters, 5-round stripper clip, effective range, 500 yards, exceptionally accurate, but bolt action. No matter how skilled the rifleman, no matter how fast he worked the bolt, he could sustain perhaps 10 to 15 aimed rounds per minute. The mechanical action required time. Physics couldn't be rushed. The operational mathematics were brutal. One American Marine with an M1 Garand could deliver the sustained firepower of 3 Japanese riflemen with Arisakas. In any engagement where Americans weren't outnumbered by at least 3-to-1, Japanese infantry faced a firepower deficit that courage couldn't overcome. Reports like Tanaka's began filtering up the chain of command throughout August and September 1942, Guadalcanal, New Guinea, each report, variations on the same theme. Enemy equipped with semi-automatic rifles, sustained fire, heavy casualties before close engagement. By October, captured American equipment reached Tokyo for analysis. 20 M1 Garands in various stages of wear. Salt corroded from jungle humidity, but still functional. The initial assessment at Yokosuka Naval Arsenal was guardedly optimistic. Japanese engineers ranked among the finest in the world. They'd successfully reverse-engineered British Vickers machine guns, German optical sights, Czech pistol designs. The M1 Garand was sophisticated, certainly, but it was mechanical, no magic involved. Gas tapped from the barrel drove a piston. The piston rotated a bolt. The bolt extracted the spent case and chambered a fresh round. When the 8th round fired, the empty clip ejected with that distinctive ping American veterans would remember for the rest of their lives. Tests at Yokosuka proved the basic concept sound. Captured M1s successfully fired Japanese 7.7 millimeter ammunition. The cartridge dimensions were similar enough, not identical, but within tolerances. The gas system cycled. The rotating bolt locked. The rifle functioned on the test range.
With good ammunition and careful maintenance, the American rifle worked with Japanese rounds. By January 1943, optimism began shifting towards something heavier. Engineers stripped down multiple M1s, measuring every dimension, analyzing every component. The tolerances were extraordinary. Machined to 0.0001 inches, spring tempers requiring specific steel alloys not readily available in Japanese inventory, gas port dimensions precise to thousandths of an inch. Any variation caused cycling failures. The N-block clip system alone involved 8 separate moving parts, each requiring exact dimensions to function reliably under field conditions. More troubling were the American production documents recovered from Guadalcanal, administrative papers in a captured headquarters. Springfield Armory alone was producing 600 M1 Garands per day by January 1941, 600 rifles daily from one facility. Total American production by war's end would exceed 4 million M1s. Each rifle built to identical specifications, parts interchangeable between rifles manufactured in Massachusetts and rifles manufactured in Michigan. A soldier could field strip 2 M1s, mix the parts randomly, reassemble 2 functioning weapons. Japan's entire rifle production for 1941, all models, all arsenals, totaled 162,000 bolt-action Arisakas. Different arsenals maintained different tolerance standards. A bolt from Kokura Arsenal wouldn't reliably fit a receiver from Tokyo Arsenal. Parts weren't truly interchangeable, even within the same model designation. The engineers began understanding what they faced. They weren't being asked to copy a rifle. They were being asked to replicate an entire industrial system. The precision forging dies, the hardened tool steel, the controlled atmosphere heat-treating furnaces, the century and a half of accumulated manufacturing knowledge dating back to Eli Whitney's development of interchangeable parts in American armories. They were being asked to compress decades of industrial evolution into months. But the order, when it came in February 1944, was absolute. Imperial General Headquarters, produce a semi-automatic rifle. Yokosuka Naval Arsenal received the assignment. Designation, Type 4 rifle. Target, mass production by 1945. Initial order, 250 part sets for testing and refinement. The quiet understanding among the engineers was never written in official reports. They'd been ordered to perform industrial magic with resources that were already collapsing. American B-29s were systematically destroying supply chains. Steel allocations were being diverted to aircraft carriers and fighter planes. Ammunition quality was declining as chemical supplies dwindled. The Empire's industrial capacity was being consumed faster than it could regenerate, but orders were orders. Japan would build its answer to the M1 Garand, or die trying. Spring arrived at Yokosuka Naval Arsenal in 1944 with cherry blossoms and impossible deadlines. The chief engineer, a meticulous man who'd graduated from Tokyo Imperial University in the 1920s and spent 2 decades watching Japan's military consume resources faster than industry could produce them, spread American technical drawings across his desk alongside preliminary sketches for what would become the Type 4 rifle. The challenge wasn't copying the M1 Garand's operating principle. The challenge was building it with what Japan actually had. The design phase revealed itself as a cascade of necessary compromises. The engineers made intelligent adaptations, replaced the American unblock clip system with a 10-round internal magazine fed by 2 5-round stripper clips, the same clips Japanese soldiers already used with their Arisakas. Troops knew how to load stripper clips. Manufacturing stripper clips required less precision tooling than producing those 8-part N-block mechanisms. Keep the heart of the Garand system, the gas-operated rotating bolt, because that was where the semi-automatic magic happened. Switch to a Japanese tangent rear sight instead of the American aperture sight, because Japan simply didn't have production capability for aperture sights at scale. Use a 2-piece wooden stock instead of single-piece walnut stock, because Japan's hardwood resources were already allocated to aircraft propellers and rifle stocks for existing production. On paper, spread across the chief engineer's desk, it looked like brilliant improvisation. The Type 4 would actually have 2 more rounds than the M1. It would use familiar loading procedures. It would leverage existing supply chains and soldier training. The modifications seemed sensible, even superior in some respects. But each adaptation created effects that rippled through the entire system. The modified magazine changed receiver dimensions, requiring new forging dies. The tangent sight altered the sight picture and would require different training protocols than American forces used. The gas port had to be recalibrated for Japanese ammunition, which operated at different pressure curves than American .30-06 rounds. The two-piece stock changed the rifle's harmonic vibrations during firing, subtly affecting accuracy in ways that wouldn't appear until live fire testing. The invisible problem was manufacturing precision. American M1 production relied on infrastructure Japan couldn't replicate. 50-ton forging presses for receiver blanks, hardened tool steel for rifling buttons that could produce thousands of barrels before wearing out, controlled atmosphere heat-treating furnaces that could maintain exact temperatures for exact durations to achieve proper steel hardness without brittleness.
Most fundamentally, interchangeable parts manufacturing. The legacy of Eli Whitney and the American system that had been refined over 140 years of weapons production. Japan in 1944 operated with aging machinery, much of it purchased from Germany or Britain in the 1920s. Priority steel allocations were going to Zero fighters desperately trying to contest American air superiority and to warships that could no longer venture from port without being sunk. Skilled machinists who understood precision tolerances were being drafted into infantry units to replace casualties. Power shortages from Allied bombing of electrical infrastructure meant factory equipment ran intermittently or at reduced capacity. Summer brought the first prototypes. 20 Type 4 rifles, hand-assembled by master craftsmen who fitted each part individually, filing and adjusting until components mated properly. These weren't production weapons. They were proof-of-concept demonstrations, each one essentially custom-built. Test results came back mixed in ways that revealed fundamental problems. Best case, 40 rounds fired without malfunction. Typical case, jamming after 15 to 20 rounds. Worst case, failure to cycle on the first shot, requiring manual operation like a bolt-action rifle. The problems clustered around predictable failure points, gas port fouling. Japanese powder formulations left more carbon residue than American propellant, gradually choking the gas system until insufficient pressure reached the operating rod. Magazine feed lips bending under spring pressure because available spring steel didn't match American alloy specifications. Extractor failures from inconsistent heat treating. Some extractors were too soft and deformed under stress. Others too brittle and cracked. Ammunition quality variations causing extraction problems when cartridge case dimensions weren't consistent. An engineer's report from August 1944, later captured by American occupation forces, contained a sentence that summarized the entire endeavor. The American rifle succeeds not through superior design alone, but through superior ammunition, superior metallurgy, and superior quality control at scales we cannot match. The mathematics were becoming impossible to ignore. American M1 production by mid-1944 exceeded 4,000 rifles per day across multiple arsenals. Springfield, Winchester, International Harvester. Japanese Type 4 production consisted of 250 part sets ordered, with perhaps 100 potentially assemblable into functioning rifles. American ammunition, uniform brass cases, non-corrosive primers, consistent powder charges measured to within half a grain, was being produced by the hundreds of millions of rounds annually. Japanese 7.7 millimeter ammunition was experiencing increasing quality control problems as chemical supplies for primer compounds became scarce and waterproofing steps were skipped to save costs and time. The moment that crystallized everything occurred on a test range in late summer. A Yokosuka engineer conducted a direct comparison test. One pristine Type 4 rifle, fresh from assembly, carefully inspected. One captured M1 Garand, well used, showing wear but still functional. Both rifles firing identical Japanese 7.7 millimeter ammunition from the same production lot. Same temperature conditions, same test protocol, same shooter. The M1 Garand cycled 80 rounds without a single malfunction. The Type 4 jammed on round 23 when the extractor failed to pull a spent case from the chamber. The engineer cleared the jam and continued. Another failure at round 47, another at round 62. Same ammunition in both rifles, same environmental conditions. The only variable was the rifle itself. The engineer filed his report with characteristic precision. We have copied the parts, but not the precision. Each American part fits every American receiver. Each of our parts fits only the receiver it was made for. We are building 250 custom rifles, not a production weapon. He understood what his superiors didn't want to acknowledge. The Type 4 project wasn't developing a weapon system. It was exposing the gap between Japanese industrial capability and the demands of modern mechanized warfare. By autumn, even the optimists at Yokosuka were running calculations that led to the same conclusion. If Japan somehow managed to perfect the Type 4 design, if every technical problem was solved, if production actually began, the timeline meant perhaps a few thousand rifles by war's end. Meanwhile, American factories were adding 4,000 M1 Garands to inventory every single day. The United States was producing more semi-automatic rifles in a week than Japan could hope to produce in a year. The chief engineer kept working because orders required it and because Japanese professional culture demanded commitment regardless of outcome. But he'd stopped believing in victory. Now he was simply trying to give Japanese soldiers something better than what they had, knowing that better would still be vastly inferior to what they faced. The Type 4 wasn't going to change the war's outcome. At best, it might give a few soldiers a slightly better chance of survival in battles Japan was going to lose anyway. Fall brought cold rain to Yokosuka and the slow realization that even a perfect Type 4 rifle would be defeated by the collapsing ecosystem around it. While engineers struggled with gas port dimensions and extractor springs, American industrial capacity reached scales that moved beyond competition into a different category entirely. The contrast wasn't subtle. American small arms production for 1944 totaled 2.3 million M1 Garands, 2.8 million M1 carbines, 1.4 million other weapons, over 6 million firearms in a single year. Japanese small arms production for the same period was collapsing under systematic bombing, material shortages, and workforce depletion that no amount of engineering skill could compensate for. But the rifle itself was only half the weapon system. The other half was ammunition. And by late 1944, Japanese ammunition production was failing in ways that made the Type 4's technical problems almost irrelevant. American 3006 specifications, documented in captured technical manuals that Yokosuka engineers studied with something approaching envy, revealed the foundation of M1 reliability. Brass cartridge cases precisely drawn to exact dimensions, then stress-relieved to prevent work hardening, non-corrosive primers sealed against moisture infiltration, double-based nitrocellulose powder, graphite-coated to prevent fouling in the gas system, copper-jacketed bullets held to weight tolerances of plus or minus 1/2 grain. Quality control included random sampling with chamber pressure testing and accuracy verification at 100, 300, and 600 yards. Every round manufactured to the same standard, every round interchangeable. Japanese 7.7 millimeter reality by late 1944 existed in a different universe. Brass was increasingly replaced with steel cases because copper supplies were exhausted. Steel cases rusted in tropical humidity within weeks. Waterproofing shellac coating applied to primers and case mouths was often skipped entirely to save both materials and production time. Powder quality varied batch to batch as supply chain disruptions forced manufacturers to substitute ingredients and alter formulations. Bullet weight showed variations up to 5 grains because precision manufacturing required time and attention that ammunition plants no longer had. Quality control had become increasingly haphazard as skilled inspectors were drafted and replaced with minimally trained workers just trying to meet production quotas. Marines recovering Japanese positions after battles were noting the deterioration in their intelligence reports. Hand grenades that failed to detonate because moisture had compromised the fuse mechanisms. Mortar shells with visibly cracked propellant charges. Rifle ammunition showing surface corrosion even in sealed boxes. Stripper clips with bent feed lips from poor steel quality that made loading difficult and sometimes impossible. One captured Japanese supply officer's diary contained an entry that summarized the systemic failure. We are asked to provide first-rate weapons with third-rate materials. The soldiers deserve better. The Empire cannot provide it. The cruel irony was that the Type 4's modifications made it more dependent on ammunition quality, not less. The M1 Garand succeeded partly through tolerance of variation. Its gas system, while requiring precision manufacturing, included a gas cylinder plug that allowed field adjustment to compensate for ammunition pressure differences. American ammunition was so consistent that soldiers rarely needed to adjust it, but the capability existed. The design included margin for error because American engineers understood that combat weapons needed to function under imperfect conditions. The Type 4, adapted from the Garand's principles but manufactured without equivalent precision tooling, required even more consistent ammunition to function reliably. The modified magazine system was less forgiving of cartridge dimensional variations. The recalibrated gas port had narrower operating parameters. Japan was attempting to build a precision instrument with imprecise tools, to be fed by imprecise ammunition, all while facing an enemy with effectively unlimited supplies of both rifles and ammunition manufactured to exacting standards. A woman named Fujiwara Keiko understood this better than most.
Promoted to ammunition quality inspector at a Nagoya plant when skilled men were drafted, she spent 12-hour shifts measuring cartridge cases with calipers and rejecting rounds that would have been rejected in 1941. Except by late 1944, rejecting substandard ammunition meant troops received nothing at all. The choice wasn't between good ammunition and bad ammunition. It was between bad ammunition and no ammunition. She let rounds pass inspection that she knew would cause malfunctions, extraction problems from weak brass, misfires from damp primers, dangerous pressure spikes from inconsistent powder charges. Every day she approved ammunition she knew could kill the soldier firing it as easily as it might kill an enemy. Her technical training came from 3 years at a watch factory before the war, learning precision measurement and quality standards. She could examine a cartridge case and predict exactly how it would fail. Thin brass at the case head meant rupture under pressure. Poorly seated primers meant hang fires or duds. Variations in overall length meant feeding problems in magazine-fed weapons. She documented the failures in inspection logs that no one read because everyone knew the problems and no one could fix them. The supply chain for quality brass had been destroyed by submarine warfare. Chemical plants producing stable propellant formulations had been bombed. The skilled workers who understood ammunition manufacturing were dead in the Philippines or starving in New Guinea. By December 1944, the numbers told a story that technical skill couldn't rewrite. M1 Garands in American inventory exceeded 3.5 million rifles. Type 4 rifles assembled at Yokosuka numbered fewer than 100. And none had been issued to troops. American industrial capacity for 1944 produced more weapons than Japan manufactured during the entire war. The United States could lose equipment at catastrophic rates and replace everything within weeks. Japan was fighting with irreplaceable weapons that couldn't be maintained because replacement parts didn't exist and couldn't be manufactured because the factories were being systematically destroyed. Yokosuka engineers understood by early 1945 that they weren't building a weapon system anymore. They were building a monument to industrial inadequacy, though no one could say that explicitly. The Type 4 project continued, not because success was possible, but because admitting failure
meant admitting the war was already lost. Japanese organizational culture didn't allow for honest assessments when those assessments contradicted national policy. So engineers kept filing reports, kept testing prototypes, kept documenting failures that everyone knew couldn't be fixed. One engineer would recall years later, after the occupation, when speaking honestly carried no penalty, "We copied the Garand's design, but a rifle is not just its design. It is the factories that make it, the alloys that form it, the ammunition that feeds it, and the logistics that sustain it. We copied the blueprint, but not the nation that created it." He'd understood that truth by mid-1944, but couldn't voice it. The Type 4's failure was inevitable from the moment the project began, not because Japanese engineers lacked skill, but because they lacked everything else. The gap wasn't knowledge. The gap was a century of industrial development that couldn't be compressed into 18 months, no matter how many engineers worked, how many hours, with how much dedication. The final test results filed in February 1945 showed the Type 4 achieving 60 to 70% reliability under controlled conditions with the best available ammunition. The M1 Garand operated at 99% reliability under combat conditions with standard issue ammunition. That gap, 30 percentage points, represented the difference between an industrial power at its peak and an industrial power in terminal collapse. Early 1945 arrived with American forces island hopping toward the home islands and Imperial General Headquarters issuing orders that existed in a parallel universe from physical reality. The Type 4 rifle received a direct command, ready for mass production by summer to arm the defense of Japan proper. Engineers at Yokosuka, who'd spent months documenting why this was impossible, received the order with the silent understanding that orders weren't requests. Feasibility was irrelevant. The command had been issued. Work would continue. March brought the final comprehensive field evaluation. 30 assembled Type 4 rifles, representing the best examples from months of development, underwent testing by combat instructors who'd survived campaigns in China and the Pacific. The test protocol was straightforward. Fire 200 rounds per rifle over 3 days, simulating actual combat use with minimal cleaning between sessions. The baseline for comparison was the weapon they were trying to match. Results documented what everyone already knew but hadn't formally recorded. M1 Garands, 0 to 2 malfunctions per 200 rounds fired. Magazine feed failures were rare. Gas system fouling was minimal. Extractor breakage was effectively non-existent. Overall reliability exceeded 99%. Type 4 rifles, 15 to 45 malfunctions per 200 rounds. Magazine feed failures were common. Gas system fouling became severe after 50 rounds. 3 rifles suffered complete extractor breakage, rendering them inoperable. Overall reliability ranged from 60 to 70% under controlled test conditions, with the best available ammunition and immediate armor support. The operational verdict filed by the senior instructor was professionally tactful but clear. Not ready for field deployment, not close to ready. Unlikely to become ready within any realistic timeline given current industrial conditions. He didn't write what everyone understood, that issuing Type 4 rifles to troops facing M1-equipped Americans would be sending them into battle with weapons more likely to jam than fire when needed most. April brought orders that ignored testing results entirely. Production planning continued. Factories were theoretically identified, though none had the precision machinery required. Die casting equipment was requisitioned from sources that no longer existed because Allied bombing had destroyed them. Training manuals were drafted for a weapon that didn't work reliably. Logistics officers calculated ammunition requirements for rifles that would never be issued. The entire apparatus of military planning proceeded as though technical reality could be overridden through administrative determination. Then physics intervened in ways that no amount of planning could overcome. American B-29 raids intensified against Japanese cities throughout April and May. Nagoya, a major arms production center, received sustained firebombing that destroyed entire factory districts.
Supply chains for steel, coal, and machine tools that had been strained for years finally collapsed completely. Civilian food rations were cut to starvation levels, 1,200 calories per day in cities, less in rural areas. Industrial workers were literally starving while trying to operate machinery. The Imperial Navy, which had sponsored the Type 4 project, effectively ceased to exist as a fighting force when the battleship Yamato was sunk on April 7th during a suicide mission toward Okinawa. June and July brought the final unraveling. Okinawa fell on June 22nd after 82 days of fighting that demonstrated exactly what M1 armed Marines could accomplish. American forces suffered 20,000 casualties. Japanese forces, military and civilian combined, suffered over 100,000. The firepower differential that Captain Tanaka had witnessed at Guadalcanal 3 years earlier had been refined and amplified into systematic destruction. Any remaining steel in Japanese inventory was allocated to kamikaze aircraft for homeland defense and to coastal fortifications being built for the inevitable invasion. The Type 4 production plan was quietly shelved without formal cancellation. Engineers were simply reassigned to emergency weapons programs, hand grenades, bamboo spears, anything that could be manufactured with the collapsing industrial base that remained. By August 1945, the contrast had moved beyond stark into absurd. The United States had over 4 million M1 Garands in inventory, arming troops globally, combat proven across every theater. Every rifle manufactured to interchangeable specifications with parts that could be swapped between weapons built years apart at different factories. Japan had approximately 100 Type 4 rifles assembled, gathering dust at Yokosuka Arsenal, never issued to troops. Each rifle essentially custom-fitted during assembly, representing hundreds of hours of skilled labor for weapons that couldn't reliably fire 200 rounds without malfunction.
August 15th. Emperor Hirohito's voice came through radio speakers across Japan, announcing surrender in formal court language most citizens barely understood. At Yokosuka Naval Arsenal, 20 Type 4 rifles sat in a storage room where they'd been placed months earlier. The engineers had known since mid-1944 that the project was doomed. They'd continued working because Japanese professional culture demanded effort regardless of outcome. Orders hadn't been rescinded, so work continued. Now, the Emperor's voice made continuation pointless. One engineer would remember standing in the arsenal courtyard listening to that radio broadcast and feeling two contradictory emotions simultaneously. Grief for the nation's defeat, the collapse of everything his generation had been taught to believe about Japan's destiny, and relief that he would never have to send a soldier into battle carrying a Type 4 rifle he knew would fail when that soldier needed it most. The weapon had been a technical failure, but issuing it to troops would have been a moral failure. At least the war had ended before that happened. American occupation forces arrived in late August and discovered the Type 4 rifles during systematic inspections of Japanese military facilities. 20 rifles were confiscated for technical intelligence analysis. An American ordnance officer examined them with the professional eye of someone who understood precision manufacturing. He noted the hand-fitting marks, the file marks on internal parts where components had been individually adjusted, the inconsistent finish quality. He recognized immediately that these weren't production weapons. They were prototypes masquerading as a production run. His report, filed in 1946, contained an error that would persist in historical records. He labeled them Type 5 rifles, a misidentification based on incomplete information about Japanese weapon designation systems. The error didn't matter. What mattered was his technical conclusion, which was respectful but devastating. A crude copy of the M1 Garand, manufactured with insufficient precision and intended to fire inadequate ammunition. No evidence of combat use, no evidence of reliable function. represents Japanese attempt to replicate American semi-automatic rifle design without corresponding industrial infrastructure. The Type 4 project had cost Japan thousands of man-hours from engineers who could have been employed on weapons that might have actually functioned, scarce steel and machine tool resources that could have maintained existing production. Most significantly, it had cost credibility with military leadership who'd been promised a wonder weapon that never materialized. By war's end, the gap was unbridgeable. American factories were producing over 4,000 M1 Garands daily. Japanese factories were producing 0 Type 4 rifles per month and would never produce any. The rifle intended to save Japan had become evidence of why Japan lost. Proof that industrial wars are won by industrial capacity, not by engineering cleverness or warrior spirit or any other intangible quality that Japanese military culture had valued over material reality. The Yokosuka facility sat silent in late August 1945, its machinery idle, its workers gone home or reassigned to reconstruction duties. The American technical intelligence team that walked through its halls included a Springfield armory engineer who'd spent 3 years designing production tooling for M1 Garand manufacturing. He understood precision weapons production the way a concert pianist understands music. Not just the technical specifications, but the entire culture of craftsmanship and systematic process improvement that made consistent quality possible. He examined the Type 4 rifles with genuine curiosity rather than contempt. They were interesting failures, which meant they were instructive. The design adaptations showed intelligence. The 10-round magazine was arguably superior to the unblocked clip for tropical conditions where moisture made that distinctive ping of an empty clip ejecting potentially dangerous. The gas system demonstrated understanding of operating principles, but the execution revealed everything. Hand-fitting marks where parts had been filed to mate properly, inconsistent surface finish suggesting different levels of skilled labor applied to different components, tolerance variations visible even without precision measuring equipment. His report was professionally generous in the way that experts can afford to be when examining the work of other experts who simply lacked resources. The Japanese engineers were highly skilled. They understood the Garand's principles, but they lacked the industrial infrastructure to execute at scale. They tried to skip 50 years of manufacturing evolution. The deeper lesson emerged from comparing not just the rifles, but the entire systems that produced them. The M1 Garand wasn't solely John Garand's genius, though his design was brilliant. It was the cumulative output of 140 years of American interchangeable parts, manufacturing dating to Eli Whitney's contract for muskets in 1801. It was Springfield Armory's institutional knowledge from producing rifles since 1794, continuous organizational learning across generations of engineers and machinists. It was the American steel industry's ability to produce consistent high-quality alloys at scales measured in millions of tons annually. It was a reliable electrical grid that kept precision machinery running without interruption. It was a deep talent pool of skilled machinists protected from the draft because defense industry work was classified as essential. It was an ammunition industry producing billions of cartridges annually with quality control that made every round functionally identical. Japan had attempted to copy the rifle without copying the nation that created it. The Type 4 project assumed that design knowledge was the critical factor when actually design knowledge was perhaps 20% of what made the M1 Garand successful. The other 80% was infrastructure, institutional knowledge, supply chain reliability, quality control culture, and industrial capacity accumulated over more than a century. Yet there was dignity in the attempt itself. Japanese engineers hadn't been foolish or incompetent. They'd been handed an impossible task with diminishing resources and ordered to succeed regardless of material reality. The project files, now being archived by American occupation authorities, revealed sophisticated analysis, creative problem-solving under constraints, and repeated warnings to leadership that the timeline couldn't be met. The engineers had known by mid-1944 that Japan had lost the war industrially. They'd continued working because professional duty demanded it and because soldiers deserved their best effort, even when that effort was insufficient. One engineer's post-war interview, conducted by American Technical Intelligence in 1946, captured the essence. We knew by 1944 that Japan had lost the war industrially, but we continued because our soldiers deserved our best effort. The Type 4 failed, but not for lack of trying. There was no shame in that statement, only acknowledgement of material reality. The war had been decided by steel production, electrical generation capacity, machine tool inventories, and logistics networks, unglamorous factors that military academies spent less time teaching than tactics and strategy. The numbers made the story undeniable. American steel production in 1944 totaled 81.3 million tons. Japanese steel production the same year reached 5.9 million tons, a ratio of nearly 14 to 1. American electrical generation was 279 billion kilowatt hours against Japanese generation of 35 billion, a ratio of 8 to 1. American machine tool inventory exceeded 1.5 million units, while Japanese inventory was estimated at 200,000, more than 7 to 1. Precision rifles require precision tools. Precision tools require electricity. Both require steel. The foundation determined what could be built on top of it. The M1 Garand had succeeded because it was the product of an industrial civilization at peak capacity, fully mobilized, with resource access spanning a continent and supply chains protected by naval dominance. The Type 4 had failed because it was the product of a nation that had exceeded its industrial capacity years earlier, now being systematically dismantled by strategic bombing while trying to fight across an ocean it no longer controlled. General Patton had called the M1 the greatest battle implement ever devised, but that assessment was only half accurate. It was the greatest mass-produced battle implement ever devised. Mass production was the superpower. The rifle was merely the expression of it. By 1957, when the M1 Garand was finally retired from American military service, over 6 million had been manufactured. Many remained in civilian hands for competitive marksmanship, still firing flawlessly 80 years after their design, a testament to engineering that prioritized reliability and manufacturing processes that ensured consistency. Fewer than 25 Type 4 rifles survived in museum collections and private hands. They were rare, valuable to collectors, historically significant, not because they succeeded, but because they represented ambition without foundation. In 1944, a Japanese infantryman with a Type 99 Arisaka faced an American Marine with an M1 Garand across battlefields from Saipan to Peleliu to Iwo Jima. The Marine had 3 times the sustained firepower, backed by unlimited ammunition manufactured to exacting standards, supplied by industrial capacity that produced weapons faster than combat could consume them. Japan had tried to close that gap by copying the Garand. But the gap wasn't the rifle. The gap was the century of industrial evolution behind the rifle, the boring, unglamorous accumulation of manufacturing knowledge, the systematic refinement of processes, the infrastructure investments that seemed wasteful until war revealed them as essential. You can copy a design on paper in months. You cannot copy the industrial ecosystem that makes that design producible in any timeline measured in years. The Type 4 rifle proved that lesson at the cost of resources Japan couldn't afford to waste. The M1 Garand proved it by remaining in service long after the war ended, reliable as always, doing exactly what it was designed to do because everything behind it had been designed to make that reliability inevitable. Japan tried to copy a rifle. They needed to copy a nation. The lesson wasn't about weapons. It was about systems, about the invisible infrastructure that determines what's possible before the first blueprint is ever drawn, about the accumulated knowledge that can't be compressed, borrowed, or skipped, only built slowly over generations. The Type 4 rifles sitting in museums today are reminders not of Japanese engineering failure, but of a fundamental truth about industrial warfare. Victory doesn't go to the side with better ideas. It goes to the side that can turn ideas into reality at scale, repeatedly, reliably, for as long as the conflict demands. The Japanese engineers understood the M1 Garand perfectly. They just couldn't build the world required to manufacture it.